So this is a concept of AutoML and what we can do beyond AutoML in automatic fashion. So there's a 20 minutes, so I want to take a little bit time to explain our view of how automation can help you in a very high level. So we believe that there are four aspects, four pillars that automation can help you. One is accelerate. Another one is democratize, augment, and operationalize. So accelerate, this part is kind of easy to understand because this is automation technology. So you can turnaround time of data science machine learning project is significantly shortened. And basically, this is very important for even very experienced data scientists because eventually, even if you have the automation tool, you need a lot of try and learn process, test and learn process, because in many cases, you have a lot of ways to solve the one problem, but you don't know how to do that, or you have a lot of problems you can solve. For example, if you are building some customer scoring model, and then domain expert provide customer segmentation information, maybe gender, age, simple segmentation, or more complex segmentation. Do you want to build a model per each segment, or you want to build one global model across the segment? Basically, you don't know. You have to try. Or one problem can be formulated by classification problem or regression problem, which is a better way. You have to try. So there's a lot of idea you can try, but and automation help you to accelerate your trial and run process to find out the best way to solve the problem or to allow you to solve more problems. So this is the one way that we believe automation is going to help you. Another part is democratize. So today, in a polls, not many people said you have the challenge to hire data scientists, lack of data scientists. But many organizations are still struggling to have the strong data science team. And basically, the democratized data science, the concept is to allow more people to execute a data science project, machine learning project. And basically, so 1/3 of this room are data scientists. So I want to tell this democratized data science is not only for BI or analyst type of people, but if we can allow them or enable them to execute machine learning project, then experienced data science team can really focus on something important, something more technically challenging. Because a lot of data science team is currently, have too many work, data engineering work, or a lot of templated project. But this project, even non-data scientists is going to be able to solve using automation. But data science team can really focus on very challenging problem. So democratization is not only for someone who is not familiar with machine learning, but eventually our view is there is no citizen data science team or data science team, but it's overall data science or machine learning practice as an organization. And this is something we're really proud of. So augmentation means that, first of all, automation is not something to replace the domain expertise. It cannot. That domain expertise is your core business insight. That is extremely important. But what automation can help is to expand this insight. Because in one project, maybe you can explore only 100 of hypothesis features. But automation can explore millions of features per project. And of course, there's only many features that's only statistically relevant and not so meaningful for business. But there's a lot of features our customer found that there's a very interesting new discovery. So just imagine you can use more data that you have not yet fully used and what kind of insight you can discover if you can use tens of tables in one project. Last part, I'm not going to dive into the detail in this presentation, but this part is increasingly important area in any AI machine learning project because at the end, a lot of machine learning project is still in experimental environment lab, but it has to be integrated in business environment, business system, and operated in business. So operationalization is one of the key areas, and it's not very easy because typically data science lab versus production environment, there's a very different type of requirement. And even data science team do not recognize this difference when they are building model. And once it comes to the production, suddenly scalability issue or maintainability issue, or there are different type of problem appears. This is a title. Does AutoML replace your data scientist? I have kind of already answered this question. Basically, it's not something, automation is not something to replace expertise. And expertise and automation, we have to distinguish them. And so then, how are we going to, how expert can use the automation? So this is one way to see automation and manual, mixing automation with your expertise. So if we are looking at a feature, there's an interpretability dimension and there's a predictability dimension. So more predictable feature versus more interpretable feature. These two directions is not necessarily aligned. And yellow triangles are features based on domain expertise. And the blue dot are features automatically generated. And basically, the ideal situation is we have a lot features in this area, highly predictable and highly interpretable. But it's not always the case, right? Some features are very, very strongly correlated with target variable, but it's just, for example, pseudo correlation, and it's not necessarily real causality. Or there's some very highly interpretable feature that you really like, it matches to your intuition, but it's not as predictable as the other features.
When you say predictability, you mean predictive power?
Yeah, predictive power, predictive power. So there's a different features, and at the end, you have to choose and combine these features to build the machine learning model. And if once it comes to the model, again, same dimension can be applied, interpretability and predictive power. And there's a certain area, we call this automated decision making. This area, usually we need a less interpretability because anyway, decision is automatically happened and interpretability is less important. It doesn't mean that we don't need interpretability because if prediction makes some wrong decision, you need some retrospective analysis. So even automated decision making, interpretability is very, very important in enterprise. On the other hand, there is another area what we call the machine-guided decision making, which means that, for example, you have the field sales people and you build a scoring model. Oh, your customer is going to churn, so why don't you follow up? Oh, 80% of score. But the field sales cannot trust that. We cannot say because deep learning said. Right? We need to clearly show, okay, these are the key factors that machine used to produce this score. That's why machine believes that your customer is going to churn. So this type of case, so basically these two area difference is who is going to make the final decision. So automated decision making is basically, it's more like a policy, and decision is automatically made based on policy. On the other hand, machine-guided decision making, it's more like information to the expert, and final decision is made by expert. This area, we need more interpretability. And the last area is kind of extreme. Like some data science projects does not require any prediction, but they are trying to find insight and discovery through the prediction model. So this knowledge discovery area, usually interpretability is considered much more important than prediction itself. So eventually you have to identify what are your use cases and how you can combine the automation and your expertise. And basically the best practice is include the expert and automation in the same loop. Right? So there is a project that is templated, easy to solve. Maybe automation can automatically solve it. Or as I said, your domain expertise are one of the most important assets. So that we call the domain features. So combine domain features and automated generated features and mix the best feature set by leveraging both capability, your expertise and automation. Once you come up with, combine these two, then certain project accuracy is more important. This type of project, in our past experience, AutoML is going to do a very good job because it can search more hyperparameter space and fine-tune your algorithm. On the other hand, in many regulated industry-regulated model, you cannot simply use AutoML. You have to carefully manually choose the features and control the model. That case, you still can take advantage of automatically generated feature, but you have to manually customize the model. So this is just not which is good or which is bad, but very different cases. So basically, again, best practice is to include the both capability, your expertise and automation in the loop. One thing is data. We are named as a leader. This is important. But one thing is Forrester just published in May this new report, very focused on this AutoML, automation-focused machine learning solutions. So which means that attention and importance of this AutoML is rapidly increasing. And this technology area is going to be very mature in next 2 to 5 years. So a lot of people have already started to adopt AutoML. And if you are interested in, please come to us and let us discuss more. So this is the end of my presentation. Yeah. There's a couple of questions. So one is, so it's just a question. So you can just input your question. Or if you have a question, you can also raise your, Okay. Okay.
So you also create the right features by looking at the SQL queries that you posted.
Mm-hmm.
These are derived composite features from data you already have. Sometimes it is necessary because the cardinality of different tables don't quite match.
Yeah.
So you have to aggregate somehow and do some sort of aggregation. But otherwise, it may not be. Now, what occurred to me is that, fine, you have to create the flat table. Because typically it is a homogeneous set of entities that machine learning will operate on and features and so forth.
Yep.
However, as far as the derivation of complex features, I mean, isn't the whole idea of using things like neural networks and other complex machine learning hypothesis generation sort of methodologies is that it allows you to avoid having to think about complex features, and it'll actually create feature transformations and discover composite features through training.
Yep.
So do we need this?
Yes. First, I'm going to, I have a couple of answers to your questions. So first, in terms of neural network, so first of all, neural network is very, very good for generating feature for unstructured data, image data, voice data, video data. That's how they make the breakthrough, right? Because traditionally, these unstructured data, manual feature is very, very difficult to design. And that's why neural network type of algorithm is making a very significant breakthrough in accuracy. On the other hand, if you look at this data, right, there are still, for example, image data is still kind of homogeneous information. Neural network is not necessarily can handle this kind of very, very data distributed in different tables. Because one reason is that this is a technical session, so I want to now dive into the technical. Neural network type of thing are basically the world of linear algebra, right? Matrix computation. But this kind of distributed tables and queries, these are not linear algebra world, but very different computation. And basically, neural net architecture does not fit in this type of data. And that's why neural net itself cannot directly consume this type of data. So that's why even if you are going to use a neural network, you have to once aggregate the data in a single table format. That is a starting point even for neural network for this type of data. Unstructured data is a very different story.
But then once you create the flat table, is your work done, or do you need more?
That's a good question, actually. Once we create a flat table, actually, we are generating certain interaction type of features, right? A and B type of features. We are going to generate it. And that type of features are, I think we are going to generate. And a little bit challenging part of interaction feature we are seeing is that the interaction make only sense, right, for certain context. And A times B or polynomial transformation type feature usually generate something very difficult to understand. That is our experience. So we are actually generating these features, but typically that nonlinear transformation is exactly the same with that what neural network is internally doing or boosting is internally doing. So it's depending on which part of feature or machine learning you want to enforce a nonlinearity. So that part is basically your choice to which is suitable for you.
So among all the things that you described, which kind of moves from data engineering to feature engineering, in my mind, actually, I might be wrong, the hypothesis generation is possibly the most challenging or difficult. Yep. Can you elaborate how you do it? I mean, if it's possible at all to describe it.
Actually, that part is our secret sauce. So that part, but there's a. I'm a little bit hesitating because we know that there's a couple of AutoML people in this room. So there's the CEO of A2 over there. So but the thing is, basically, it's not. So first of all, our features are so there's an expression. Right? Expression means that how feature looks like. Because it's too much over complex feature, at the end, automatically generated feature is very, very hard to understand. So first of all, our algorithm is designed to generate a certain type of query that makes sense for expert. And then it comes to how we generate the hypothesis space, right? How can we generate hypothesis among this expression? So that part is, we have the kind of machine learning algorithm actually inside this feature engineering to generate this type of query. So we do not have the hardly coded, for example, set of query in advance, but we have some algorithm to automatically generate this type of queries. But it doesn't mean that we can just generate features that only makes sense for domain expert, but actually our feature engineering explores usually millions of features literally, and half of them, or maybe 60% of them, are garbage, right? That is automatically filters during the process. So hypothesis generation is definitely a very, very difficult part. So that's why we have the generator, hypothesis generator, and hypothesis selector not to produce a meaningless hypothesis for the machine learning. Yeah. Sorry. Yeah. Maybe. Yeah. We can have the closer session somewhere. Yeah.
Yeah. Hi. Quick question regarding the technical integration. If I understand correctly from your slide,
Yep.
then you have many tables in their enterprise. Some of them in CSV, some of them in Oracle DB, some of them in Hive, and so on. And usually in those enterprises, you see many different databases.
Right.
So are you integrating directly into those databases and putting the data out of there?
Yeah, there's a couple of things. So we have the JDBC framework or certain, for example, CSV import framework. So we can connect certain type of database already. And of course, there's so many databases in the world. So it doesn't mean that we can connect all of them.
Right, but so my real question for that. So basically, if you explore such a vast space of hypotheses, that means that you run thousands and millions of different queries on those databases.
Yeah.
So that means that you need to integrate directly into those databases.
No, actually, queries are, though the exploration will be done on the distributed memory. So basically, taking data on the memory, and then the query processings are basically executed on memory. And it doesn't mean that we have to load all the data in advance, because we have this kind of smart, lazy evaluation. So only required data is
right. So only the
memory.
data that actually have in the target table, the one with the label, basically, you need all of that from the database. That means that you need to execute a join somewhere between the
But
data.
not on the database side, but it once loaded on memory side, and processing is going to be done on memory side.
Right. But in order to pull the data in, you need to somehow execute the join itself
Right.
between the targets. So that means you can't really execute that on the distributed memory because you don't have all the data.
We can.
Okay.
Yeah.
Cool.
We can, and maybe we can talk a little
that'd
bit
be
more. But
interesting. Cool.
yeah, we can perform a lot of this kind of complex integration work on the memory side, and basically the final result is produced to the distributed storage side. So, we know that the enterprise database side, we cannot run the query freely, and we have to run this query in a different place. Real-time integration means
Interactive data flow. Right?
Oh, I see.
Real-time data, and keep adjusting model based on the flow. Do you support such model operation?
So first of all, in machine learning projects, there's a training phase and prediction phase, right? And training phase, I don't believe that we need a real-time integration, because it's eventually you need a lot of manual validation work afterwards. And the prediction phase, we are not yet there to fully support the real-time, but more like a mini batch type of integration. But we are, yeah. Sorry.
Last question.
Oh, last question? Yeah. But I'll be there, so if there's more question, please. Yeah.
So one of your slides in the past, I saw the feature selection portion prior to your AutoML. But from my experience, feature selection works hand in hand with the training part. So how does that work?
Oh, yeah, that is, I think, a relevant question. So feature selection can work in both places. And basically, let me talk about our product design. In our product design, first of all, feature data and the feature engineering phase, there's so many hypotheses we have to validate. And basically, in this phase, feature selection, our product believe that recall of feature is more important, which means that we can include irrelevant feature in this phase. Because as you pointed, machine learning itself has a feature selection. So including irrelevant features is OK. But we don't want to miss an important feature, right? So feature selection in this data and the feature engineering stage, we have some objective function to not miss an important feature, although we can include the irrelevant features. And then it comes to machine learning. Machine learning has different feature selection mechanism, right? So boosting algorithm or support vector machine, regularization, different algorithms have the different feature selection. And integrated approach versus the separated feature selection component. And this can be, this is actually part of the AutoML. So yeah, that is true. Yeah, so this is the last question. So yeah, thank you very much for active participation in the polls and also the Q&A. And if you have any further follow-up question, please come to .data desk, and I'm happy to interact with you. Thank you.